Hi friends, in the last video we had a look at alpha decay equations, and today we are going to have a look at beta decay equations. So we are going to learn how to write certain equations when certain elements undergo what we call beta decay. So what exactly is beta decay? When you take a look at this image, you realize that we have 2 neutrons and 1 proton. While after the arrow, the product side, you shall have 2 protons and 2 neutrons. So in this case, beta decay will always occur when a given atom usually has more neutrons than protons, or when the proportionality of the two is not that good enough for that element to be stable. So in this case, we shall have a single neutron turning into a proton and an electron. As you can have a look at this neutron here, it will turn into a proton and then an electron at the same time. So that means we shall always form a new element because we shall have a different number of protons. And remember, atomic number is always what determines an element. When you look at beta decay, we shall somehow simplify it by writing a neutron turning into a proton and an electron. So what happens is that during beta decay, that neutron will always cause a removal of an electron, and this speed moving electron, this electron when it's moving very fast, is what we shall refer to as beta decay. This electron that will be removed from the nucleus, while the proton will always remain in the nucleus. So we can also write the notation of these subatomic particles the same way we write notations of an atom. So here we have a neutron, one mass number, and then proton and an electron. Still the sum must be equal. Mass number is 1 both sides, while the atomic number will always be 0. 1 plus -1 must give us 0. So that's basically what beta decay is all about. A neutron turning into a proton and an electron. And this moving electron is what we usually refer to as the beta decay or the beta particle. So let's have a look at some common equations and how we can predict an element which will be formed as a result of beta decay. When you have a look at this equation, we have carbon 14 undergoing beta decay because we have a beta particle, which is our electron, being formed on the right-hand side of the arrow. So our main thing to do here is to identify which element will have been formed as a result of this beta decay. So at the start, we shall realize that we have 6 protons from this super subscript here. Number 6 shows that we have 6 number of protons, the atomic number. So for us to realize the number of neutrons, what we shall do is we shall have to subtract the number of protons from the mass number. So 14 minus 4 minus 6, we shall get 8. So the number of neutrons of carbon will be 8. So in this case, what we know that as a new element is being formed, the old element will have gained 1 more proton because one of these neutrons will turn into an electron and a proton. So the new atomic number must be 6 plus 1, which is 7, while the new mass number will have decreased by 1. So when you have a look at that, you shall realize that the number of protons will now have increased by 1. Like we have seen the previous slide, beta decay is all about a neutron converting into an electron and a proton. So we already have our electron here, so our proton will now be added to the atomic number, so it will be 7. And then the mass number will also decrease by 1 because the neutron has changed into a proton, which will also be 7. Then we shall go to our periodic table and try to identify which element has atomic number 7, and we shall realize that it's actually nitrogen. So when you realize that element, we shall just have to put the atomic notation of that element, nitrogen, capital N, subscript 7, and then for us to get the mass number or atomic mass of this new element, we just simply have to add 7 plus 7, which is 14. And this will be our beta decay equation. So basically in beta decay, all you need to know is that a neutron in the nucleus of that unstable atom will turn into a proton and an electron. So in this case, we know the products. Beta decay can also be written like this Greek symbol here, beta, the second element in their alphabet. So they can either put here an 8 to represent an electron, or they can use this very symbol, the Greek letter beta. So in this case, we have sulfur and beta. So we want to identify the substance that underwent this kind of decay. So in this case, we shall say that our sulfur has atomic number 16, but we know that the element before must have had one proton less, because in beta decay we always have an increase in the number of protons. So we shall obviously be having a smaller number by 1. So we shall have probably 15, because 16 minus 1 shall get 15. So our previous elements must have had 15 number of protons. And the same will apply to neutrons. The neutrons must have been at least higher than the number of neutrons in the new element. So we shall have 17. So our new element has atomic number 15. So go to the periodic table and we shall discover that actually phosphorus. So we shall put phosphorus where we have our question mark. Remember, mass number will remain equal, while atomic number will also somehow decrease. So let's have a look at it. So when you have a look at this, you realize that the mass number 32 is 32. Atomic number we will have increased by 1 from 15 to 16. So mass number remains the same, because even if the neutron turns into a proton and an electron, we shall always have that proton part of it. So somehow the mass number remains the same, because when one neutron turns into a proton and an electron, its number has gone into the position of the protons. So mass numbers will always be equal. That's why we have 32 here and then 32 on the right hand side of the arrow. However, the atomic number will always increase by 1. Phosphorus had 15 and then now sulfur has 16. So it has somehow increased by 1 because the neutron had turned into a proton. So basically this is how we can write this kind of equations. So we are going to use a shortcut. Instead of following with the number of neutrons and protons in this equation, we shall just know that the mass number will remain the same, while the atomic number will always increase by 1. So we have here iodine 131, mass number will remain the same, so our new element we expect it to have 131. However, the atomic number 53 we expect it to increase by 1 because of the change of a neutron to a proton. So our new element must obviously be having 54 as the number of protons for this new element. So we have to go to the periodic table and try to identify our new element, and we shall discover from the periodic table that the new element is known as xenon. So Xe is our new element, so writing the mass number, it will always be equal to the previous element, which is iodine. So 131 will also be our mass number. So this is beta decay. As you can see, we have a beta particle here, and this equation will also be complete. One more equation. Yes, in this equation, I'll give you a couple of seconds. Feel free to pause the video and try it out. Okay, yes, thank you. I believe you were able to identify the element that underwent this kind of decay. So we have our beta particle here, and we have cobalt 52. So remember, in beta decay, the old element or the element undergoing this kind of radioactivity will always have equal mass number compared to the new element, and it will also have the number of protons less by 1. So if we have cobalt 27 as its mass, as its atomic number, the previous element must have had 1 proton less, because cobalt must have gained the proton as a result of beta decay. So in this case, our element must have been having 26. So in the process of beta decay, this 26 gained a proton and became 27, while the mass number must remain the same. So from the periodic table, we shall realize that iron is this element that underwent this kind of beta decay. So mass number will remain the same, while atomic number will increase by 1. So this is how we can write beta decay equations. In our next video, we shall have a look at how we can write alpha decay equations, and maybe somehow compare alpha, beta, and gamma radiations. Those who haven't watched alpha decay equations, please check out that video that we have already looked at. Yes, thank you for watching. Feel free to add any comments in the comment section. If at all you have a question or an idea on how we can make these videos better. Yes, thank you for watching once again.